review graphs of polynomial functions. You take a look at it. First one's linear. It's in simplified form and factored form. Remember, simplified form is the easiest way to see what the y-intercept is. Okay, it's a constant term because y-intercept is when x is 0. So that's exactly. Factored form, if it's in factors, we're trying to find all the values of x that make each factor 0. So the only one there is 3. It's a linear function, so degree 1. So it has no max or no mins. Domain and range, I'm just going to abbreviate, not all the notation, right? Element of the set of reals. So that was math 10, math 20, quadratics, so degree 2. Simplified form, so y-intercept is -8. X-intercept, if it's in factored form, whatever x's make each factor 0, so -2 and +4. Okay, so there will be, in this case, a max or a min. How can you tell right away? Remember, if the leading coefficient is positive, then the parabola is opening up. That means you'll have a minimum, not a maximum. Okay? You can graph it on your calculator. You could complete the square, right? Put it in vertex form. Or, based on the information that's given, what you can do, remember, these are your x-intercepts. What's the x value of the vertex then? In between, equally in between. It's the average of those. So -2 plus 4 is +2 divided by 2 is 1. So when x is 1, what's y? So 1 in there, I would put it in here, or you can put it in there, but 1 minus 2 is -1, minus 8 is -9. Or here, 3 times -3 is -9. So that's your relative minimum. Okay? You don't have to complete the square on it. So domain and range. Domain for all polynomial functions is all real numbers. If it's an even degree, remember there will be only certain values to the range. If it's an odd degree, it'll be all real numbers. So even degree, it's opening up, so it's y greater than or equal to -9. Again, I'm not putting the whole squiggly brackets, all the notation. Not enough space there. You can if you write small. Okay? Next one, you could do the same. I'm going to leave that for you to do. That's degree 2 again. This one's opening down because of that leading coefficient. So there'll be a maximum, right? Not a minimum. Remember the property that the maximum number of x-intercepts is equal to the degree. Okay? So degree 2, most number of x-intercepts will be 2. You could have 1, could be just the opening. If this is the x-axis, it could just be opening there, right? That's touchy. You could have none. Okay, but you can't have 3. Right? Because it's degree 2. I'm not sure. I haven't looked that up. In terms of turning points, so a turning point is where it goes from going up to down or down to up. Okay? And so you can tell the maximum number from the degree. Okay? So it doesn't necessarily mean that is the number of them, but it's the maximum that you can have. So degree 2 means the maximum number of turning points is 1. Okay, so that means it's not going to turn and zigzag twice, right? That would be a higher degree. So in this case, it's a parabola, it's going to have 1. Okay, degree 1 will have 0 turning points. Makes sense. None here, right? Okay, so that's a little review of that. So then in degree 3, all right? So this is degree 3. take a look at the simplified form. So the y-intercept is -6. You put 0 in for x, so all the terms go away except for the last one. X-intercepts, what value of x makes each of these 0? So that would be -2, 1/3, and 3. Remember, opposite sign of the constant, divide by the coefficient. Okay, so there's 3 of them. I just got to check which first column is minimums, right? Okay. If there's 3 x-intercepts, then it's going to have turning points, right, in order to get there. So the degree is 3. In this case, it has 3 x-intercepts. Remember, and that's the maximum that a cubic could have. It could have 1, but in this case, it has 3. So it's got to cross and come back. So there's going to be a 1 max and 1 min. What do we know about domain and range? Who can tell me what the domain and range is? No use of a calculator. How do you know? Yeah. Okay. X domain is always all real numbers for polynomial functions, unless it's an application where we're restricting the domain. So all real numbers, X element of the set of reals, and then because it's odd, I call it the disco move, right? They're going in opposite quadrants. So that's going to be Y element of R. You guys probably don't even know about disco because you're so young. But you probably, back in the historical records, seen some stuff about disco. I'm actually a little too young for disco. My sister is. Anyway. So let's graph this. Now, after you guys oohed and awed over my last calculator yesterday, it crashed. So here is a different one. It's not color, but it does the same. And this, I have to press it twice, which is really annoying. So in any case, going to enter. You decide which version. They both should be the same. I'm going to enter. So basically, I have to press
every button
twice. Yeah.
Oh, that sucks.
I got to figure out. What to do. Anyway, so we might be trying to find some money to get the legit version so that we don't have to do this all the time. Okay, I'll go with because we know our x-intercepts. They're not big. Our standard screen is -10 to +10. So I'm going to start with a standard screen. We might not be able to see the maximum. We can't, but you can see that it zigzags. So now I'm going to change my Y window. I'm going to go to like -50. Sorry, -50. +50. Okay. Perfect. I can see it. You didn't have to go to 50, but now you can see that zigzag. Okay, so remember how to find your max and min. Okay, so if I do min, that's number 3. It asks me for the left boundary, so there's where my minimum is. So this is where it's annoying. I'm just going to go to the left of where I think it is, enter on that. Okay, to the right, enter on that. And then it'll say guess, but it's a very good guess. Okay, now saying that, sometimes it depends on where you put those boundaries. This is essentially -1. So you have to do a little bit of deductive reasoning in that sense. Okay, it's not really 0.999. If I now put in, if I'm in trace mode, and then I put in an x value, so trace, and I put in -1, it assumes that's for x. Enter on that, it goes to -16. And really what? That's the minimum. That's the minimum point. The minimum value is -16. Now, it's not the overall minimum, right? Because it's all real numbers. So remember, that's why we have the word relative minimum and relative maximum. And that's going to be important when you get to calculus too. Because you're going to learn how to find those minimums and maximums without a calculator. Remember, you don't have a graphing calculator next semester. Okay, there's a few different ways, right? Basically, derivatives is going to be learning how to take a derivative. That will be your best friend. It will tell you a lot of information, right? That will be next semester. In this case, this is a relative minimum because really negative infinity is the minimum, right? So -1, -16. And then do the same for the maximum. So second trace maximum. Get closer. Okay, and then enter. Okay, and again, what is it there? So I think we said nearest hundredth. So you can tell that's going to be 1.89. We'll just go to the nearest hundredth on that, and 20.16. Okay. It really might be 18.9 if we 1.89, 20.16. Okay. 1.89, 20.16. 1.89, 20.86. Right, question? Oh, 1.6, yeah, sorry. Okay, so then we get into degree 4. Take a look here when it's factored. It actually has a factor of x, right? So in terms of our intercepts, our y-intercept here, there is no constant term, so the y-intercept is 0, okay? And so there you can see, so we'll go through the origin. X-intercepts 0, -4, -5/2, +2. Okay? Every factor that has x in it, that gives you your x-intercepts. I'm not going to spend the time graphing and using max and min. You can do that on your own. Saying that for the domain and range, I can't tell you what the range is without graphing it because it's degree 4. So that's the yay mode, right? 2 up or 2 down, both ends. In this case, it's a positive leading coefficient, so they're going up in both directions. So again, you always know that it's all real numbers, but now if it's going up, it's going to be greater than or equal to something, whatever the smallest y value is. So you're going to have 2 minimums, minimum points, and whatever the smallest y value is. Okay. And then degree 5. So again, no constant terms, so y-intercept is 0. X-intercept, we look at the factored form, so 0, -3, -1, 2, and 4. We did this work for you, okay? It's degree 5, so the domain and range is all real numbers. You don't really have to think about anything. Okay. Notice how there are 5 x-intercepts. Now, it could be that you have a graph, and we're going to get a whole into transformations. I told you that yesterday, right? But maybe, let's say you have a graph. Let me do this. Let me do. Well, this is positive, so it's going to be like this. So let's say we have a graph like that. Okay, it's degree 5. got 5 there. No changes in there, but if I moved this up, which is going to be easier if I just move the x-axis down to that, it's still a degree 5, but it's just been translated up, okay? And it will only have one x-intercept in this particular case. So that's why the degree gives you the maximum number of x-intercepts, okay? Really, we kind of call these, it's not really a math word, but the sides of the polynomial. So there's 5 sides here, 1, 2, 3, 4, 5. That, again, there's a maximum number of 5 sides. Remember, for like a cubic, if I do a cubic on here, that's y equals x cubed. It only passes through once. Right? Yeah, so it's called a change in concavity, exactly. There is a change. There isn't a min or max, right? So it's 0 for that. But that's the maximum number of x-intercepts is 3. This only has 1.
I know how you always told us in math funny of you to assume the lowest multiplicity.
Yeah.
How does the change in the concavity change? Like, let's say if you do like whatever the factor is to the 99. Like, is it literally like a straight line at that point?
Yeah.
Yeah.
Exactly.
Okay. So is there a way to calculate the amount of change in concavity? Or you can get to that?
Calculus, you'll talk about the slopes of the tangents. Yeah, so that slope would be very steep, as opposed to y equals x cubed, it will be less. Okay, so, what did I just do?
Oh, that's the recording window.
Yeah, I know. Give me a second. This is going to pause. Okay, in question 2 it says sketch 1D, sketch 1E. So 1D and 1E. So if we did 1D, 3 x-intercepts. One of them is negative, 2 are positive. Okay, so again, it's a sketch. 1 is negative, 2 are positive, kind of like that. The scale, we're not going to do a scale for a sketch, right? Y-intercept is negative. It's got a negative leading coefficient. So that always reminds me that I'm going down and to the right. Okay? So a negative leading coefficient, no matter if it's even or odd degree, is going down and to the right. Okay? So we often call it the end behavior, and it's really the end of that graph. And then, so then I can join it up like this. Okay, disco arms, right? It's odd degree. Degree 3, and then you can label those values. So what was that? -2, 1/3, 3. So, and then here, so this could be better. I should stretch it out a little bit more, right? In terms of, it's not great scale, but here, I'm just going to do this. Give me a sec here. Just because it's a -6. So we go down like this, that, and then let me look at my minimum, because it kind of looks like I made the minimum on the y-axis. So the minimum is -1, -16. So I need to kind of go down more here. So I'm going to actually make this first. Okay, and then this was, again, I could make this a little bit better. You're not drawing a scale. It's definitely a sketch, so I'm not going to be too picky, but you have to have them in the right, approximately, certainly the right quadrants, right? 1 point, Okay. In any case, zigzags, and you want to label important points. I'm going to leave one E for you to do. You can always check with your calculator. Again, change your window so you can see those max and mins. Question 3, there's connection between the degree and the shape, connection between the sign of the leading coefficient and the end behavior, sketch a possible graph, so degree 6 with positive leading coefficient, so I know it's going up and to the right at the end. If it's an even degree, then, woohoo, yay, up at the left. Arms are going up, okay? And then if it's degree 6, you got to have 6 sides. Whether it goes through all of the x-axis 6 times, or it's like 1, 2, 3, 4, 5, 6, right? Because it could be a translation. And we'll get more into translations later. It's got to have those 6 sides. Degree 7, negative leading coefficient, so one down and to the right. And it's degree 7. Just don't move. So this has got to go up here. Okay? And then 7 through there. You can make them x-intercepts as well. 1, 2, 3, 4, 5, 6, 7. I'll just erase this arrow. Okay. You turn again, you kind of got to flip it to the next question 4. Another chart that says don't use your calculator at all. Notice how it's not going to ask you for your maximum and minimum points, because you would need your calculator until you learn calculus. So I'm not going to go through all of these. Let's go to sort of a harder one, because you've done cubics last year a little bit. Oh, that again. In any case, let's go to the last one. Okay. So first column is the degree. So you want to look at all the x's in each factor. What's the degree of each x in a factor? So in this case, that's x to the 1. It's going to be multiplied by this x, by this, by this, by this. So 1, 2, 3, 4, 5, degree 5. If this was, say, 2x squared in there, then it would be degree 6. Okay? So it's not just the number of factors, it's the degree of x in each factor. Okay? And if you multiply those x terms together, what would you get? So I'm just going to erase that, but just be aware of that. Next column, sign of the leading coefficient. Again, make sure, because some of these factors might not be having the x first. Maybe it'll say x minus, 1 minus x. Or sorry, maybe here, 4 minus x. Yeah, exactly. So you need to be careful. If you expand it out, what's the leading coefficient? Not necessarily in factored form, right? So here, I would need to, when I expand out and multiply all the x terms, I actually get a negative. So even though there's no negative there, this has a negative leading coefficient. Yep. Yep. But it's not given to you like that. So you have to know to do that. Yeah. So this has up here, a negative leading coefficient. This one is negative, positive, 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 positive. So this has a negative leading coefficient. So both of them have negative leading coefficients. X-intercepts, so X-intercepts, that is which we often call zeros of a polynomial function. So x-intercepts are 0, -7/4, -1, 3/2, and 4. Okay, all the values of x that make each factor equal to 0. Not a very big place to sketch it, but again, it's a sketch. So, want to place the x-intercepts appropriately. So we've got 2 that are negative. So we've got -1, let's say there. I'm going to just change my. So -1 and -7/4. Then I've got 0. And then I've got 3/2. And then I've got 4. Okay. Negative leading coefficient. So this is going to be going down and to the right. It's degree 5 and there are 5 x-intercepts. So you basically have the zigzag through. Question 5 is really just an exercise in expanding. So some algebra skills for that. So you're given the zeros of the polynomial function, which are like the x-intercepts. You have to put it in factored form. So it's basically the opposite of what we just did there. So if this is a 0, that's the same as an x-intercept, right? Then polynomial function, so we need y equals, or p of x equals, or something like that. And then each factor representing this. So x plus 5. So x minus -5, x minus 3/2, but we never show factored form with fractions. So that would give us 2x minus 3, x minus 4. Okay, and then you can do the expanding on your own. Okay. Now, is there another factored form that would work? Yeah. You have a negative in front. That's still a polynomial function of degree 3 with those x-intercepts. This is not saying that it has to open down and to the right. It could open down and to the right, or it could open up and to the right. Okay, so you could have a negative out front. This one here, just be careful when it's the 0 there. You put in just x. Okay, that comes from this. And we like to put the x out front rather than in the middle, because that's in the middle there, but we like to put it just so we don't miss it. And then that would be 3x minus 7. And again, it could be positive or negative. And you can expand that out. I don't need to spend the time on that. All right, so we kind of got into this a little bit about the shape of a graph, the degree of the polynomial function. And so now when it's in factored form, all of these so far, the exponent on the factors has been 1. We haven't even had an exponent because it's understood to be 1. So all of those zeros, or x-intercepts, have had a multiplicity of 1. But what if we had a squared on one of the factors? Then that would be considered to have a multiplicity of 2 at that x-intercept. If it had a cube, multiplicity of 3. And there's a shape that is associated with each of those repeated factors. So that's what is in the next note sheet, so I'm just gonna